Quadratics graphing test review. I'm working on the evens for you guys. So if you have any questions, since we won't get a chance to review before the test, here you go. So this one's in standard form. Standard form, your axis of symmetry is negative b over 2a. Not a fan. Okay, in this question, b is 8, so that'd be negative 8 over 2 times 1. So x will equal negative 4. X equals negative 4. Okay, then we're going to plug it in. Plug in negative 4, see what you get out. Negative 4 is our line of symmetry. Our vertex is always on our line of symmetry. So I'm plugging in negative 4. Negative 4 squared plus 8 times negative 4 plus 19. I'm not going to waste your time. I'm just going to throw it into a calculator. I get 3 when you plug in negative 4. You get 3. Negative 4, 1, 2, 3. Y-intercept, you always plug in 0. 0 squared is 0, plus 8 times 0 is 0, plus 19. 0 plus 0 plus 19 is 19. 0, 19. That means this graph is opening up, and a is 1, so it does. Extra point, 1a, 3a, 5a. A is 1, so 1, 3, and 5. So from my vertex, I go up 1, right 1, and reflect it. From my new point, I go up 3, right 1, and reflect it. So any of the points I just drew are good extra points. Just name one of them. If it opens up, it has a minimum, and the minimum is always the y of your vertex. So minimum 3. So that's standard form. Parentheses squared is vertex form. Y equals a, parentheses x minus h squared plus k. Vertex is hk. Anytime you come out of the parentheses, you change the sign you see. So if you see a negative 3, it's a positive 3. This negative 3 isn't coming out of parentheses, so it will stay a negative 3. So 3, negative 3. Axis of symmetry always goes through your vertex. So if your axis of symmetry is 3, the x of your vertex is 3. If the x of your vertex is 3, the axis of symmetry is 3. Y-intercept, plug in 0. Negative 0 minus 3 squared minus 3 is negative 9, 10, 11, 12. Negative 12. 0, negative 12 is off the graph, which means it'd be going down. So 1a, 3a, 5a would be negative 1, negative 3, negative 5. Negative 1, negative 3, and negative 5 would be off the graph, but that'd be where your y-intercept is. So you know you did a good job there. It is a maximum, and it's the y of your vertex. That is what makes this graph a maximum, have a maximum. Intercept form, a parentheses x minus p, x minus q. Your x-intercept is p0, q0. So coming out of parentheses, change your signs. Negative 4, negative 2. Quadratics are symmetrical. So after you draw your two x-intercepts, the line in the middle is your axis of symmetry. Your axis of symmetry is always the x of your vertex. So we're going to do negative 3. So we get 1 and negative 1. So 1 times negative 1 is negative 1. 1, negative 1. That agrees with our slope of 1. Up 1 over 1. Up 3 over 1. Y-intercept looks like it'll be off the graph. If I plug in 0, it'd be 4 times 2, so 8. So 8 is off the graph. When you do extra point here, just try not to use your vertex or your x-intercepts because I was already labeled those. So that's graphing. We went over 7 in class together. Moving on to 8. Is that equal to 0? It is. Factor. What multiplies to your constant adds to your middle term. So 2 and 1 with a 2 being negative. Set both equal to 0 and solve. So x equals -1, x equals 2. X equals -1. Open circle because it's greater than, open circle. At -1, open circle. At 2, open circle. Test points. You can test 3 to make sure every interval is correct. The easiest one is to test the middle. If I plug in 0, I have 0 squared minus 0 minus 2 is greater than 0. So -2 is greater than 0. -2 is not greater than 0. So it's not in the middle, meaning it's on the outside. If you tested another point like 3 or 4, I tested 4, 4 squared minus 4 minus 2 is greater than 0. 4 squared is 16 minus 6. 10 is greater than 0. And it is. 10 is greater than 0. So that's why over here at 4 is part of our answer. The part people had trouble with, you can pause this video, rewind it, watch it as many times as you want. So if you need to go back and get what I just deleted, please go do that. People had trouble writing an inequality form. With inequalities, you're doing x first. Then, and if you do x first, then you can always follow this arrow. So x is less than, not equal to, because there's no line underneath it. X is less than -1, or because I jump over a section, x first, x is greater than 2, because I'm following this arrow. So always write your x first so you can follow your arrows. If you don't write your x first, then you have to think of the logic of the statement. So a lot of people here try to do 2 first with then x. They're like, how do you know the symbol? Well, you just made it hard on yourself, because if you had put the x first, then you could have followed your symbol, followed your arrow. But since you decided to put the 2 first, because that's what you saw, now you have to think of it. We want numbers greater than 2. So we want numbers greater than 2. So 2 has to be less than other numbers. That was way more complicated. So these are numbers greater than 2. Way harder than just following your arrow, putting your x first. Same thing, just harder. Okay. Interval notation, and then this question is done. So this is going left forever, -infinity to -1, parentheses because it's open, and then 2 to infinity. There you go. 10, set equal to 0. Factor, a is 1 here, so these are easier factoring than 9 and 11. 9 and 11, you had to slide, divide, and multiply. Slide, divide, slide, factor, divide, and multiply. Only one thing multiplies to 3, and we're going to add to the bigger number. So you want the bigger number to be positive. So x minus 1, x plus 3 equals 0. Set both equal to 0, and solve. A lot of people remember as, oh, flip the signs. You're flipping the signs because you're solving this. I'm minusing 3 over, so -3. So those are where our dots go. Less than 1, open, because it doesn't have an equal to line under it. -3, open, and test points. Test. So I'm going to test 0 because it's easiest. 0 squared minus 2 times 0 minus 3 is less than 0. So -3 is less than 0. -3 is less than 0. That's true. So I shade in between. If you tested outside, it would say false, so you know you did it right. This is an and problem because they're going together. Also less than. So it's an and problem. Remember the other one was great or, so ors go away from each other. And you're writing a compound inequality. So x is in the middle. It's always pointing to the left, and the smallest number first. So -3 goes first, 1 goes last. There's your compound inequality. What that's saying is x is less than or equal to 1. So arrow going this way. And you're flipping this. X is greater than or equal to -3. But you have to write it as a compound inequality. And then interval notation is the easiest, I think at least, from -3 to 1. Parentheses because they're open circles. Brackets if they're closed circles. All right. Inequalities in two-dimensional, x and y. So we graph it. This is in standard form. -b over 2a, -4 over 2 times 1, so -2. Plug it in. 4 minus 8 is -4 plus 6. I think it's -2. I'm going to pause and check. And I was wrong. It's a +2 because I plugged in -2 to my equation. Make sure the squared is on the outside of your -2, and you get +2. Which makes sense because I didn't even give you that part of the graph. -2, +2. Y-intercept 0. When you plug in 0, 0 plus 6 is 6. So 0, 6, and reflect it. And then by slope, 1a, 3a, 5a, you can find the other one. The other two, sorry. So there's your graph. What makes it an inequality is how we draw the line. Remember, if it's greater than or equal to, less than or equal to, it's a solid line, just like the lines underneath are solid. If it's just greater than or less than, it's a dotted line because that line is missing. And so is part of our graph. Part of that graph is missing. So here's a solid line, so I'm going to draw a solid graph. On the one we did in class today, it was a open, so I had a dotted line on my quadratic. And then we need to know where to shade. So you have to test a point. The easiest point to test, obviously, is 0, 0. I've done that one all the time. So x is 0, y is 0, and I'm plugging it in. So 0 is greater than or equal to 0 squared plus 4 times 0 plus 6. So 0 is greater than or equal to 6. 0 is not greater than 6. So at 0, 0 right here, this is false. This is not a solution. So outside is false. That means inside is true. So when it says possible solutions, you just want to choose a point inside your parabola. So I'm going to just choose -2, 3. And if you want to check it, you're more than welcome to. -2, 3. So x is -2, y is 3. So 3 is greater than or equal to -2 squared plus 4 times. Do you have to do this? No. Does it make you happy to know your answer is right? I hope so. 4 minus 8 is -4 plus 6 is +2. 3 is greater than or equal to 2. True. So we got true inside, so we know we shade it correctly. A lot of information. Still less than what should have been on the test. I broke this unit into 2 tests because I think it's a lot. Factored form. P0, Q0. P0, 3, 0, Q0, 5, 0. So 3, 5. So our line of symmetry is at 4. So that's where our vertex is. 4, plug it in. So 1 times -1 is -1. So here we go. My y-intercept is 0, 15. That doesn't fit on the graph. I plugged in 0 to get that answer. 0 times -3. Not times, -3. 0 minus 5. So that's 15. And then extra point, up 1 over 1, up 3 over 1. I'm off the graph. I've taken your test. All of them fit nicely on the graph with 5 points. So if yours is not fitting nicely on the graph, something is wrong. You should go back and check that you changed the signs on your, x-intercepts, or that you changed your sign of opposite B, stuff like that. So now we do possible solutions. Possible solutions. I froze. I test 0, 0 always. It's just the easiest. So 0 is greater than 0 minus 3. 0, I can't even read it. What's that, plus 5? Minus 5. So 0 is greater than 15. So this is false. So inside is true. Possible solution is anything on the graph itself or inside. Because on the graph, because our line's solid. If our line was dotted, that would not be a solution. So 1, 2, 3, 4. I'm just going to say 4, 0. And again, you can test this point to make sure it's a true. Last part is slope. So we need our 2 points. This is from this graph. So 3 is 7.85, 3.53, 0. y2 minus y1 over x2 minus x1. And it doesn't matter which one's y1 and y2, as long as if this is y2, that's x2. So if y1 is 7.85, then x2 is 3. Minus y is 0, then x is 3.53. And put that in a calculator. When you're putting it in a calculator, the easiest thing to do is hit your fraction button first and then type it in what's on top and then what's on bottom. When I put in the calculator, I got negative 14.8113. Ugly, but that's fine. It can be an ugly number. All right, the last one we need to do is from a table. From a table, we're looking at -1 and +1. So m equals y1, I'm just going to do 5, minus y2, another negative, so +1. I did 5 first, and I have to do -1 first, minus 1. So 6 over -2, -3. All right, on your table, I can fill it out for you if you want to look at it. If you're done, then you don't need to watch this. Have to know your equations. On your equations, make sure they're equations. Y equals is what makes them equations. Make sure this has a squared and this has a squared, or it's going to be points off. And then we'll go down. Axis of symmetry. X equals A, B, and C is what's the letters in this one. So negative B over 2A. Your vertex, I said it in the video already, is always the axis of symmetry. So negative B over 2A. You have to solve for y. Once you have an x in an equation, you plug in your x to find your y. Y-intercept, you plug in 0 to your equation. If you plug 0 in for x in this equation, you will always end up with c. X-intercepts, you're solving for x when y is 0. So solve, set the equation equal to, set equation equal to 0, solve for x. And you solve by factoring or quadratic formula or completing the square, all those different options. So 1a, 3a, 5a is the slope of your quadratic, and it works for everything. But if you don't like that, and I have a few students who don't like that, you can just choose x values near your vertex. The further away from your vertex, the more likely it's on the graph. So just choose x values near your vertex and plug in to find y. So whatever x you get, what you get out is your y. So then you'll have points there. Axis of symmetry, x equals. On this one, it's h. If you remember during the notes, I put a star here because anytime you can add a parentheses, you change your sign. I just want you to know that. So you don't have to write the star. I'm not going to take off points if you make some comment saying you switch your sign for h. But you don't have to write it. You're not actually switching your sign. It's because of this negative in your equation that it's a positive h. Plug in 0, solve for your y-intercept. All right, intercept form, you usually start with the intercepts because they are P0, Q0. And again, in the parentheses, you're coming out. So that's where you start when you're graphing. And then you find the middle of those 2 points. So you're adding them together and dividing by 2. That's how you find the middle. If I want to know the middle of our paychecks, I'm adding my paycheck to your paycheck and dividing it by 2 because there's 2 paychecks. All right. The x-axis of symmetry is always the x of your vertex. Opposite of what you see. Anytime you come out of your parentheses, opposite of what you see. Not opposite of what you see in here, opposite of what you see in your equation. You have to solve for y. Y-intercept is the same. Every time I'm plugging in 0. Only in standard form is it going to be c. In vertex and intercept form, you actually have to solve for it. Since you should know its opposite sign, I'm getting rid of all that because it makes it look even more complicated. But you should know that axis of symmetry is the x of the vertex. The axis of symmetry is the x of the vertex. The axis of symmetry is your x of your vertex. Okay, email me if you have any questions. I'm here in the morning at 8 a.m.